Hello, all. Good evening.
Good evening, ma'am.
Yeah, so I saw somebody posting today. You got your results. So, how was your results? Is it good? Good. Is it good?
Yeah, luckily it was good for me this time.
That's good.
Not as expected.
Not as expected. Okay. So where was the problem for you, Shivam? Okay, we'll talk about the first result later. Uh, Start the session. So today is week 6, all with us. Yeah, I told in last session we'll do a couple of visualization part for GeoGebra. So not in this class, but we are preparing some content for week 6. So we'll share with you all by the end of this week. Okay. So I hope that content will help you in understanding the topics better. For now, okay. So please go to joinpd.com and use the code HLBLGS. Wait for a couple of minutes. All those people who haven't gone to joinpd.com, just please go to joinpd.com and use this code over on the right top corner of the screen. That is HLVLGS. Okay, so let's start the session now.
Good evening, ma'am.
Yeah, good evening all. So please go to joinpd.com and use the code HLVLGS. So the first question that we have here is, you have given the joint PDF of two continuous random variable x and y, and it is defined as fxy of x comma y as k e to the power minus x plus 5 for x like x greater than equal to 0 and y greater than equal to 0. Otherwise, fxy takes the value 0. So what should be the value of k? You can enter your answer here. Um, Okay, so let's discuss the quiz result later. For now, please focus on the session. Okay. Do not put messages in the chat box. This is the first question. Please write your answers. All those people who haven't joined who haven't opened the joinpd.com, please go to joinpd.com and use this code HLBLGS. I could see only 34 people here. Please go to joinpd.com and answer the questions. Okay, let's go to responses. So I could see most of the people have answered k equal 1. So that is the right answer. So, okay, how do you find the value of k here? Anyone would like to explain?
Ma'am, can I?
Yes, Manan.
So, ma'am, first fxy is given. So first we have integrated x from 0 to infinity, then y from 0 to infinity, fxy into dy dx equals to 1, 2 times integration. So
Okay,
first
so
I have integrated fxy with respect to y. So in that I got my answer as after doing the integration, I got only e raised to power minus x. So, and then I did a integration with respect to x. So my answer was k times, and putting the limits, my answer
okay,
was k.
integration part we will see. Okay, so the basic idea, yeah, thanks, Manan. Yeah. So the basic idea was a joint PDF of two continuous random variable was given to you, and you have a constant over here, that is k e to the power minus x plus y, right? Now, using the property of the joint PDF, we know that if the integral over the whole range, integral of fxy over the whole range should give the value 1. Okay. So if you integrate your PDF over the whole range, the probability should come out to be 1. So this is what we have to use here. This property we'll use here. So once you say this, so you could see the range here is x greater than equal to 0, y greater than equal to 0, right? So x is varying from 0 to infinity and y is varying from 0 to infinity. So we will integrate our fxy dx dy where x is varying from 0 to infinity and y is varying from 0 to infinity. And this integration, the whole double integration should give us the probability equal to 1. Now, if we choose to integrate first with respect to x, okay. So since k was a constant, we can pull this constant term out, right? This is a basic property of integration. So we are putting this k outside, and first we will let's just do the integration with respect to x. So if you try to do the integration first with respect to x, your e to the power minus y, right? That will also work as a constant here. This will also act as a constant because it's we are trying to do the integration first with respect to x. So e to the power minus y will act as a constant. So we can also pull it out outside this integral of x. Okay. So once you do the integration of e to the power minus x dx, you will get e to the power minus x divided by minus 1. So as you know, integral of e to the power x gives you integral of e to the power ax gives you e to the power ax divided by a. So in this case, our a was minus 1. All right. So if you do the integration of e to the power minus x with respect to x, where x is varying from 0 to infinity, it will come out to be minus e to the power minus x, and you put the limit, and this will give you the value 1. When you put the limit of x varying from 0 to infinity, it will give you the value 1. Then once you finish the integration with respect to x, you can finish the integration with respect to y. So now you have k times integral 0 to infinity e to the power minus y dy, and this should give you the value 1. So similarly, if you do the integration of e to the minus 5 with respect to y, you will get e to the power minus y divided by minus y, right? So this minus term will come out, and again, when you put the lower limit and the upper limit, you will get the value as 1. So k will come out to be 1. Any doubt in this solution?
No, ma'am.
Okay. Let's move to the second part. So it's a continuation, it's the same PDF that we had seen in the question number 1. Okay. So now you can assume that here k is 1. Okay. So now your PDF is e to the minus x plus y, x is greater than equal to 0, y is greater than equal to 0, otherwise it gives the value 0. Now you have to find the value of what is the probability that x is greater than equal to 4, comma y is less than equal to 4. So both should happen. So what should the value come out to be? You can select your option, whatever answer you get. So let's look at the responses. So most of you have answered option B. So here we had to find the value of what is the probability that your x is greater than equal to 4 and y is less than equal to 4. Okay. And your x, both x and y are greater than equal to 0. So to find the probability, or what we will do here, any idea what should we do here? We have to find the probability that x is greater than equal to 4 and y is less than equal to 4.
Ma'am, we will take limits of y from 0 to 4, and for x, it would be from 4 to infinity, and we will integrate.
Right. So since x is greater than equal to 4 and y is less than equal to 4, and we know x is greater than equal to 0 and also y is greater than equal to 0. So once you take the limits, you will get x varying from 4 to infinity and y varying from 0 to 4. So if you integrate your joint PDF, joint distribution function over this range where x varying from 4 to infinity and y varying from 0 to 4, you will get the probability that x greater than equal to 4 and y less than equal to 4. So integration, what we had discussed in the previous slides, it's the same way you have to do the integration here. You can do the integration first with respect to x, or you can choose to integrate first with respect to y. You'll get the same answer. So it depends on you what you want, like what do you want to integrate first. And just the limit part here will change. Just the limit alone is changing here. In the previous case, we had seen x was varying from 0 to infinity and y is also varying from 0 to infinity, but here the limit has changed. X is varying from 4 to infinity and y is varying from 0 to 4. So once you solve this, you will get e to the power minus 4, 1 minus e to the power minus 4. So what option is this? E to the power minus 4, 1 minus e to the minus 4. So it's option B, right? Yeah, please go on.
I'm unable to get this answer.
You're not able to get this answer.
No,
okay?
I'm confused, ma'am.
So where are you not able to answer? Which
Not
part?
able to integrate. ma'am.
Not able to integrate. So the integration is same as the previous one. There is no change. Nothing has changed here. So in the previous example, you said you have integrated and you got the value of k to be 1. So here also the integration is same. It's just the limit part alone has changed. Can you check where have you done wrong? Which part
Yeah.
is not right?
Unable to integrate the x part.
You are unable
Actually,
to get the x part. Okay.
Actually, I have done first with respect to y, then with respect to x.
Okay. So first, if you integrate with respect to y, what will happen? Now e to the power minus x you will treat e to the minus x as a constant. So you can put this e to the minus x outside, right? So you will have now integration x to 4, x equal 4 to infinity, e to the power minus x. Then again integration y varying from 0 to 4, e to the power minus y dy dx, correct? So once you integrate first with respect to y, you will get e to the power minus y, e to the minus y by minus 1, right? So minus e to the minus 1, and integration limit is varying from 0 to 4. So what will you get? You will get e to the power 0, that is 1 minus e to the power minus 4, right? This
Yes,
is
ma'am.
1 minus e to the minus 4. And what you had from previous one, you have the integral where x is varying from 4 to infinity, e to the power minus x dx, right? This is what you will
Yes, ma'am.
have, right? Again, if you integrate with respect to x, you will get e to the power minus, so 1 minus e to the minus 4 is a constant, you can put it out. So you will have 1 minus e to the minus 4 integral x varying from 4 to infinity, e to the power minus x dx. So if you solve this, so after integration, you will get e to the power minus x 4 to infinity.
Just
right?
a second, ma'am.
Yeah.
Ma'am, here 1 minus e to the power minus 4, can't we treat it as can't we put e raised to minus x inside the bracket?
Can't we put 1 minus e to the minus?
No, my answer was minus times e raised to power minus x times e to the
Okay,
power
just
minus 4.
just getting confusing. I will write down somewhere.
Yes, ma'am, please.
Let's look over here. What we had was so first we integrated the y term. Okay, so after we integrated the with respect to y, we got 1 minus e to the power minus 4 e to the power minus x dx, and x is varying from 4 to infinity. Before this step, it is clear to you, right?
Yes, ma'am.
Before the step, even you got the same thing, correct? Now 1 minus e to the minus 4 is a constant, right? So we can pull this out. I will write 1 minus e to the power minus 4 integral e to the power minus x dx, where x is varying from 4 to infinity. Okay. Now what is the integral of e to the minus x dx? It is e to the power minus x, right? Minus. And what is the limit? It is 4 to infinity. So once you solve it, you will
Ma'am,
get,
here, excuse me.
yeah,
Ma'am, here it will be plus, not minus.
where plus?
Minus, no, it will be plus times e to the power minus x.
Why it should be plus?
Because in previous answer, it was minus times e to the power minus x times 1 minus e to the power minus 4.
Okay, let me do it the complete one. Okay. So first we had e to the power minus 5, e to the power minus x, right? dx dy. So what I'm doing is we will do the integration first with respect to y. So x is varying from 4 to infinity, e to the power minus 6, I put it out, and y is varying from 0 to 4, e to the power minus 5 dy dx. Is this correct?
Yes, ma'am.
So x equal 4 to infinity, e to the power minus x. Now alone this part, you are getting minus e to the power minus y 0 to 4, right?
Hmm.
So what will you get? You will get, if you look at just this part, then you will get minus of e to the power. I'm taking this minus term out. Okay. So e to the power minus 4 minus e to the power 0 is 1. So this becomes 1 minus e to the power minus 4. Right? Is this right? Is this clear?
Yes, ma'am.
So it is, this integration comes out to be 1 minus e to the power minus 4. That's what I've written it here.
Okay.
So it becomes 1 minus e to the power minus 4 e to the power minus x dx. Okay.
Hmm.
Now this is a constant. So I am pulling this outside. So 1 minus e to the minus 4 integral 4 to infinity e to the power minus x dx. Now just look at this integration over here. So if you do the integration, you will get this. So e to the power minus infinity, right? So you can also write it as 1 by e to the power x 4 to infinity, correct?
Yes.
So minus of 1 by e to the power infinity is infinity. 1 by infinity is 0 minus 1 by e to the power 4. So this becomes e to the power minus 4. So your answer will be e to the power minus 4, 1 minus e to the power minus 4. Is this clear?
I think I got 1 minus extra.
Yeah, okay. So I think somewhere you are missing the minus sign.
Okay, ma'am. Thank you.
Yeah.
Ma'am, I have a doubt, very basic doubt.
Okay.
If let's take just forget about moment on this problem. Let's
Huh?
take one integral 1 dx.
Okay, I will write it
So,
down. Okay.
yeah,
Yeah, what did you say? Integral.
what is the result is x within the limit
Sorry,
0 to 4. No, integral,
x 0 to 4. Okay.
yeah, x 0 to 4,
Okay.
1 dx.
1 dx.
Yeah, a constant times dx.
Okay.
So the constant is, so when you integrate that one, we get cx, is it?
Yeah, you integrate, you will get cx, right?
Yeah, but now here, when we are integrating e power minus x,
Okay.
why we are not getting e power minus x? Integral is x e power
Okay,
minus
so
x divided by minus
okay.
1. Why we are not getting that?
So what is the integral of e to the power ax? Can you tell me?
8 times e power minus a, 8 times e power ax.
Not a times. It is e to the power ax divided by a.
You are writing
Yeah,
differentiation, not integration.
Oh, sorry. Yeah, right.
That's
Yeah,
right.
you are you are integrating.
Sorry, right.
You are asking.
Yeah.
Yeah, then the answer is a power eax, no?
So you want me to integrate, right? Integrate only.
No. My simple question is, whenever we put a constant
Hmm.
and we get a cx,
Yeah, we
and
get
why are we
cx.
not getting an x along with the e power minus x?
So if you want to integrate e to the power minus x dx, right?
Yeah.
So what is the integral of e to the power ax? This is what you should.
Yeah, e to the power of ax is e power ax divided by a.
Right? Now,
Yeah.
what is the constant here?
A is a constant.
A is a constant, right? And in this,
No. I think we should really break e power ax as e power a
okay,
times e power x. So e power a is a constant, no?
e to the power a is a constant, you're saying. I
No,
think,
no, I'm wrong.
wait,
No,
see,
no.
okay, I will just go through this again. So,
You can't break it actually.
You can't break that one, right?
yeah,
But
you cannot break it.
no. My simple question is now, whenever we have a constant, we get an x.
Whenever we have a constant, we get,
Whenever we are integrating a constant,
okay,
we get x,
yes, we
and
get
within the
x.
limit we are applying it.
Yes.
And
times.
at the same token, why are we not having an x for the e power minus x?
We have e to the power x. I mean, we have an x there. So, okay. So, integral of e to the power ax dx comes out to be e to the power ax by a, where a is a constant. Okay.
Right.
Now, if you look at this expression here in e to the power minus x, what is the constant here?
Minus
No.
1.
I got to take a context differently. See, in our problem, it is e power x plus y. Okay.
Our problem it
times.
is x plus
X
y.
plus y, okay? So we are splitting that one into e power x times e power y.
Yes.
Minus x.
E power minus x, e power minus.
Yes.
Okay, whatever it is, e power y.
Hmm.
So whenever we are integrating with the dx and dy, we will be treating y as a constant, is it?
Okay.
If you are integrating with respect to x, then y is constant.
Y is a constant, so e power minus y is a constant, right?
Yes.
Yes.
Then why we are not having an x along with the e power minus y?
Okay, so you understood.
I'm taking you back to the starting thing. Whenever it is a c dx, we get a cx dx. Cx, no?
If we get a cx.
Yeah.
Ma'am,
And why
ma'am,
are we not
ma'am,
getting the x along with
ma'am,
e power
if
minus
I
y?
may interrupt.
Okay.
Ma'am, if I may interrupt.
Yeah,
please.
Actually, the expansion of e to the power x is 1 plus x divided by 1 factorial plus x squared divided by 2 factorial. It's not a simple term. It's a whole series. So when you differentiate it or integrate it, can you write it down, ma'am? E to the power x is equal to.
Okay. But we don't need the
Yeah,
series
exactly,
here.
ma'am. The gentleman is taking us into a different course actually. That's why I wanted to clarify his doubt.
Okay, okay, I will write it there, but let's see first this one. So this part is clear for you, right? E to the power minus x plus y is equal to e to the power minus x times e to the power minus y. This part is clear.
I'm with you in that
Ha,
one. That I
ha.
don't have any
Okay,
issue.
now let's look it over here. So we want to integrate this fxy with respect to x and with respect to y.
Yeah.
Now, if I want to integrate first with respect to x, okay.
Yes. Okay.
So we have e to the power minus x, e to the power minus y, dx, dy. Okay.
Yeah. Yeah.
Now you have two variable here, x and y.
Yeah.
So
You're right.
you will treat e to the power minus y as a constant because it doesn't have x.
Okay. Hold on a minute. That's the right point here. Can we call that as a C?
Yeah, you call it as a c. Let's say this is c.
Okay.
Okay. So
Now, how do we progress about?
if you do c, so I will pull this c outside this integral. Okay. So I'm writing it
No,
here.
that is a specific question I am asking here. Previously, we had a C and we get a CX. But
Yeah.
here we are taking out the C.
What? Yeah.
Can I interrupt, ma'am?
So what you will just hold on. So what you will get here is e to the power minus x dx you are doing, right?
Yeah.
And dy. So I have pulled this c outside. So c was e to the power minus y.
Right.
Now
Right.
your integral e to the power minus y e to the power minus x dx, okay, becomes e to the power minus y integral e to the power minus x dx.
Right.
Let's say this is a and b. So if you integrate this part, it becomes e to the power minus x by minus 1, right?
Yeah.
So I will write it here, and it is varying from b to a to b.
Yeah.
And this times e to the power minus y.
Okay.
Correct? So this constant term again is here. It is not going anywhere. This constant term is there.
Yeah, but it is coming as constant.
Yeah.
Right.
So the idea is same.
Okay.
Ma'am, I have a question, ma'am.
Yeah,
all right,
please.
ma'am. I got it. I got it. Right. Thank you.
Yeah.
Hello.
Yeah, Nikhil.
What will be the integration of double integration of e to the power minus x plus e to the power minus y?
सर ये 6 बजे का डीपीआर फिगर शेयर करिएगा.
Sorry.
It is e to the power minus x times e to the power minus y. What will be if it was e to the power minus x plus e to the power minus y?
बट का भी बता दीजिए.
Who was speaking?
Okay.
E to the power minus x plus e to the power minus y.
E to the minus x plus e to the minus y.
Right, ma'am.
Okay. So, see, this is not same as e to the power minus x times e to the power minus y. At that point you get, right?
Right.
Now, if you want to integrate this with respect to x.
Yes.
So, okay.
I think that was his question, ma'am.
No, that was not his question. His question got cleared. So what you are saying is e to the power minus x plus e to the power minus y dx dy.
Dx dy.
So if we integrate first with respect to x,
yes.
So we will have now this is since you are integrating first with respect to x, you will treat e to the minus y as a constant, right? You will have to treat e to the minus y as a constant.
Right, ma'am.
So integral will become, if you just look at this part. Okay?
Yes.
So this is e to the power minus x plus e to the power minus y dx, and you can separate it out, e to the minus x dx plus integral e to the minus y dx. So since this is a constant, you can pull it out and it becomes c times x. So basically e to the minus y times x, right?
Yes, that's
And
what
it
he was
becomes
saying.
e to the power minus x by minus 1. Minus this.
This is what he was asking actually.
Is it? I'm not sure.
Yeah, I think yes. This is exactly what I was
Yes.
asking, but I was not able to build up the problem. Thanks for
Okay, okay.
bringing
Okay,
up.
yeah. Yeah.
Because it was in multiplication, that's why you take some constant out and then you pull it. for the-
Yeah, yeah. Thanks for that one. Yeah, I was
Yeah.
not able to really structure out the problem.
This is plus, so
Right, good. So this is where we get the x e power minus y.
Solenoides.
Hmm.
Solenoides.
Right, good.
Antitheticals.
Okay.
Thank you.
yes.
Thanks.
Solenoid.
Thanks. Yeah. Let's move to the next problem.
Solenoides. Solenoides.
Please mute. All right. So the third problem over here is you have again the joint PDF of two random variable given to you, and it is defined as fx of y, x comma y as 3xy 1 minus x for x varying from 0 to 1 and y varying from 0 to 2. Otherwise, it takes the value 0. So calculate what is the probability that x is greater than 3 by 4 given that y is equal to 1 by 2. I'll give you 5 minutes to solve this problem, then we'll look at the solution. Right, so you could see only very few responses here. So only 16 students have responded out of 46. 3 by 22. So there are different sets of answers that we could see here. Okay. Others who have not joined the peer deck, please go to joinpd.com and use the code and write your responses there. So I could see some 77 people in the session, but only 46 have joined peer deck. So please go to joinpd.com and write your answers there. Okay, so what is it that we have to find here? You have to calculate what is the probability that x is greater than equal to x is greater than 3 by 4 given y is equal to 3 by 2. So this is a basic conditional probability, right? So once you write it in terms of joint and marginal, what should you write?
Probability of x greater than 3 by 4, comma, y is equal to 1 by 2 divided by dy, y is equal to 1 by 2.
Right. So this is the first thing that we should do here. So we know that given a random variable, like given an event, what is the probability of another event? So we know we do the joint distribution and then divided by marginal. So in this case, we had to do so this will become probability that x is greater than 3 by 4, comma y equal 1 by 2 divided by probability that y is equal to 1 by 2, right? So first, let's try to find what is the probability that y is equal to 1 by 2. So how will you find the probability y equal 1 by 2?
Ma'am, we have to find the marginalized value of f.
Marginal of f, right? So how do you find the marginal of f?
We integrate with respect to x.
We integrate fxy with respect to x. That's right.
Yes.
So
from 0 to 1. 0 to 1. Limit will be 0 to 1.
Okay, so our joint density function was 3xy 1 minus x, and we have to integrate with respect to x. So the range of x is varying from 0 to 1. Now it's a basic differentiation, integration. You have to, since you are integrating this fxy with respect to the variable x, you are treating your y as a constant, right? So you're fixing your y and just integrating over the random variable x. So y is fixed, y is a constant. So you will integral of 3xy 1 minus x. You can write this as 3xy minus 3x square y dx, right? And since y is a constant, your integral of 3xy will become 3y x square by 2, right? Integral of 3xy will become 3y x square by 2 because y is a constant and same 3 is a constant. So 3y comes outside. So 3y x square by 2. Now similarly, if you want to integrate 3x square y, it will, again, you will have to treat y as a constant, right? So again, 3y will come out and this whole thing will become 3y x cube by 3, correct? So if you solve 3y x cube by 3, it will become x cube of y, right? Now you have to take the limit from 0 to 1. So we are taking the limit for x, not don't get confused with y and x here, because x is the limit that we are taking here from 0 to 1, not for y. Y is a constant. So you treat y as a constant and just put the value lower and upper limit of x. You will get 3y by 2 minus of y, and it becomes 5 by 2. So we found our marginal probability of y. So once I found the marginal probability of y, now let's come back to the original problem. So the original problem, if you write, you have on the numerator part, you have the joint density. Okay. So x greater than 3 by 4, y equals 1 by 2. So what you have, your y is fixed, right? Your y is just 1 by 2. So we can substitute this y equal 1 by 2 in our joint distribution function. So originally the joint distribution function was 3xy 1 minus x. We can just put y equals 1 by 2 here. So if you put y equal 1 by 2, it becomes 3x by 2 1 minus x. Okay. So it becomes 3x by 2 1 minus x, and now you will just have to integrate over x. So since the range of x was given to be 0 to 1, right? So, and you have to calculate the probability that x is greater than 3 by 4. So the limit of integration of x will vary from x varying from 3 by 4 to 1. So once you solve, yeah.
Ma'am, how it is 3 by 4 to 1?
How is it 3 by 4 to 1? Because
x is greater than 3 by 4.
X is greater than 3 by 4. This is what we have to find.
And then if I have 1 by 2 is also 1 by 4.
If I have 1 by 2 is 1 by 4, that's how we have written 4xy, right?
Okay.
It came
but
to
it
numerator.
was y by 2.
Sorry.
Fi of y was y by 2.
Yes, but you had to find for, now you put y equals 1 by 2 here.
Okay.
Right? Because the y is given to be 1 by 2.
Okay.
You're fixing y to be 1 by 2. Yeah.
Okay.
I made a silly mistake only. That's why my answer was 5 by 128. That was not a silly mistake. That was a blunder. I took limit of y from 0 to half. Else everything was correct, but I took limit of y also from 0
here
to
you
half.
don't have to take the limit of y. See, you are fixing your y, right? You're fixing your y to be 1 by 2. Your y is not varying. Your y is fixed.
So say for example, if sometime x gets fixed, so in that case also we have to put the value of x and then we have to take the limit of y.
Limit of y, right?
Okay. Okay.
Since y is fixed, you just substitute the value of y in the function. And
I have one more doubt, man. Like in the denominator part, while we are calculating fy half, so fy is coming in terms of y, right?
Yes.
So basically, that is a probability density. That's not the probability, right? Because that is still a function. That is still a function. So when I am putting the value as y equal to 1 by 2, in fact, I also did it in the same way, but I'm just asking for clarification. So isn't it that I am getting the value of the probability function? It means it's a density, it's not a probability. Whereas on the numerator side, I am getting probability, right?
In the
numerator, I am getting probability because both of it is getting integrated. But in the denominator, I am getting probability density, right? It is not probability. I am just a bit confused between probability density and probability. See the marginal density of y is coming as y by 2, right? Y by 2.
So marginal density of y is
still a density function. It is still a density function, right?
Yes.
So while I am putting y equal to half, so it means I am getting the value of the function, right?
Yes, you are getting the value of the marginal density function.
Yes, value of the function. So it is still density because my function is representing density. It is not representing probability, right?
Yeah, right. This is density, right? Now, if you look at the numerator part, so again, you are just integrating your joint distribution function with respect to x.
Correct.
Correct. So, what is the general idea behind the integration? Like, if you integrate now, in place of, consider this as a function of two random variable. Okay. Now, once you fix one random variable, so it becomes since you are fixing y equals 1 by 2. So once you're fixing y equal 1 by 2, it becomes, the function becomes 3x by 2 1 minus x. So it is a function in x. So if you, once you integrate a function, what exactly do you get? You get the area, right?
Correct.
And that area gives you nothing but the probability.
Yes, so that's my question. So the numerator is giving me
similarly, if you find the marginal, right, you're fixing your y. So once you're fixing your y, again, this is nothing but you're finding the area between the curve and the axis. So again, the area under this curve that you get from Fy of y, that also this area gives you the probability.
Then the numerator part is clear, right? As you rightly said that while multiplying the density by the length, right? Probability per unit length, that is my density, right?
Density is probability per unit
Per unit
length.
length. So while when we are multiplying by dx, so this density is getting converted into absolute probability, right? So the numerator part, numerator part is crystal clear to me because that is giving me probability.
Same thing you are doing in denominator part.
But the denominator part is still a function, and because the marginal is in terms of y by 2, right?
Marginal in terms of y by 2.
It is y by 2, it is still a density function. So while I'm putting the value of y as 1 by 2, I am getting the value of the function, right? And my function is representing density, so it is still density. So how here density is getting converted into probability, that is not clear to me. In the interest of the class, we can move ahead, but this is not clear to me. That's
okay. I'll just note it down and we can discuss it after the session. Okay?
How density is getting converted into probability, right?
Yeah, we'll discuss it after the session.
So you have explained up to the equation kind of thing, ma'am. P of x is greater than 3 by 4 kind of thing.
Okay, so once you all right. So you look at the third step here. So it is 4 times 3x by 2, 1 minus x dx. Now you have to integrate this function with respect to x, where x is varying from 3 by 4 to 1. Okay, because we have to find probability x greater than 3 by 4.
I'm here y equals to 1 by 2. We are putting in the equation fxy. That's why it is 3x by 2.
Yeah, that part is 3x by 2, 1 minus x. And this 4 is coming from Fy of 1 by 2.
Okay.
Right. So again, this becomes...
So that is Fy of 1 by 2 is 1 by 4. And when it is in denominator, it is multiplying. The 4 is multiplying. That's simple.
Yes. Right. Now, similarly, you will get a function in x, and you can integrate x over, you can integrate this function over x, and the limit of x is given from 3 by 4 to 1. So 3x become 3x square by 2, and 3x square become 3x cube by 3. And the lower limit is 3 by 4, upper limit is 1. So once you solve it, you get the answer to be 5 upon 32. The basic conditional formula you have to use.
Yes, ma'am.
Okay. Any doubt here?
Ma'am, just a normal thing. If in a question, instead of PDF, it was given CDF, then this whole thing would become 0, isn't it?
Instead of
because
PDF,
y equals to half will become 0 then.
Okay, I couldn't understand. So you are asking
single point. Then it will
instead of PDF, joint PDF, if it was joint CDF.
I don't have anything called joint CDF. Yeah, I should check. I've never heard of joint CDF.
Joint CDF is not.
Yeah, let me check. I'm not sure if there is something called joint CDF.
We haven't learned joint CDF. How to calculate that?
Okay. Let me check that part also. Okay, I'm not sure if joint CDF is there.
In the lecture, sir said that it can be extended to CDF also.
Yeah, but we don't have any clear definition of how we will define joint CDF. Means how we can calculate joint CDF.
You have like 2 random variable and you'll have to integrate this fxy. Yes. Let me see that part. Not sure.
Joint CDF means x is less than equal to small x and y is also less than equal to
small x. You'll integrate it and you will have a complicated expression, I guess.
Very much.
Okay, ma'am.
Okay. Apart from that, anything else?
We can move.
Is it not when we get a CDF, we got to differentiate it to get the PDF and progress it?
Yeah, that is the user method. You integrate the PDF to get the CDF.
No. When the question is provided with the CDF, and if we have to progress the work, should we not differentiate the integration, get the PDF, and apply the limits? Is it the step or something different?
Yeah, that can be done.
It gets complicated when it is a conditional
Yeah,
and margin probability.
Too much complicated.
Yeah, it's too much. At least we have not seen an example in that.
No example, nothing, no description also. No.
I think it's mere a theoretical discussion we are making, may not be from exam point of view.
Actually, we are jointly integrating that this result itself is a CDF. I think so.
Sorry, can you repeat?
Sir, we are integrating PDF, so definitely result is CDF only.
Yeah, we are finding the probability. Yeah.
That's true. And in case of continuous random variable, we only get CDF.
Yes.
That's true.
Yes, so we can move ahead.
Yeah, let's move ahead. This is the fourth problem. Says the amount of milk in a shop at the beginning of any day is a random amount X, from which a random amount Y is sold during that day. Okay, so at the beginning of day, you had some random amount X of milk, and out of that X, you have sold Y on that day. Now you have to assume the joint density of X and Y as 2 by 25 for X varying from 0 to 5, and Y is varying between 0 to X. Otherwise, it is 0. So what is the probability that the amount of milk that will be left at the end of the day is less than 2 liter?
Means you have to calculate probability X less than 2.
So what exactly do you have to find here? You have to find probability that amount of milk left. So how much amount of milk will be left? So if you have to write this in terms of two random variables, you have a random variable X, you have a random variable Y, and how will you write this statement, the amount of milk left at the end of the day?
X minus Y?
The probability of X minus Y less than 2.
Yes, so basically you have to find what is the probability that X minus Y is less than 2.
Oh.
In the question, it has been given that X lies in between 0 to 5 and Y lies between 0 to X.
Yes. So
you cannot sell more milk than you already have. Yeah.
What?
You
cannot sell milk more than what you have.
Yeah.
Yeah.
What?
Right. You cannot sell what you cannot sell more than what you have. So you have a random amount X, and from there you are selling the amount Y. So Y will always lie between 0 to X, right? Right. All right, so we have 21 responses. 6.2. There are different sets of answers here. Okay. So what is the correct answer of this problem? 0.2. Okay, somebody else written 0.2 in the chat box. The responses, we have a lot of different answers.
1.16.
Okay. 0.6, 0.2, 0.16, 0.25, 0.8, 1.8, 0.2 again, 0.2, 0.82, 1.4. So the different, a lot of varieties of answers. Cannot decide from here. Okay. Yeah, exactly. How can someone get probability 1.8? So as we had discussed, what we had to find here is what is the probability that x minus y is less than 2. Okay. So what should you do? What should be your first step here? What should be your first step?
It is 1 minus probability of x minus y less than or equal to 2, no ma'am?
Sorry, can you repeat?
Yeah, probability of x minus y less than 2 is equal to 1 minus probability of x minus y less than or equal to 2.
Greater than.
Sorry, greater than or
equal to 2.
Yeah.
Okay. So after this, what will you do?
First, we should find that probability of x minus y greater than or equal to 2.
Okay. So how will you find that?
We have to integrate between the limits 0 to 5 for x and y for 0 to x minus 2, 2 by 25 dy by dx. That's what I did, ma'am.
X is ranging from 2 to 5, right?
X is varying from 0 to 5 here. So
yes, ma'am. I did 0 to 5 and y I did from 0 to x minus 2.
Okay, you are trying to find the probability that x minus y is greater than equal to 2, right?
Yes, ma'am.
Okay, so what is your x limit?
0 to 5, ma'am.
No, ma'am.
X is varying from 0 to 5.
For
Okay,
that, I think 2 to 5.
2 to 5. X is varying from 2 to 5.
Yes, ma'am.
And y is from 0 to x minus.
0 to 3. 0 to 2 plus y. 0 to 2 plus y.
2 plus y. Okay.
Yes, ma'am.
Anything you can take, no, ma'am. Either the
X
limit
is varying from 0 to 3 and
x minus y is 2.
And y is varying
This is
from
the
0 to 2 plus
okay,
y.
this is the figure that you get, right? So this line over here is x minus y equal to 2. Okay.
Negative intercept.
And your x is varying from 0 to 5, that is fixed. X is varying from 0 to 5 and y is varying from 0 to x. So y should be greater than 0 and it should be less than x, right? So this orange plus blue line is the reason for this whole reason D. Okay. So this triangle that you see over here, this is our reason D. And what you have to find is probability that x minus y is less than 2. So what it just told us, we'll do 1 minus probability x minus y greater than equal to 2.
Sorry, man, the blue line, blue shaded region is x minus y less than 2, right?
This line here is x minus y equal to 2, right?
Below this line, it's x minus y less than 2.
Below this line is x minus y less than 2. Yeah, right.
Right?
Yeah. So, okay. So what exactly we are trying to find here? Which probability here? Which reason?
Blue one.
Blue one. Okay.
Yeah.
Ma'am?
Yeah.
I think it will be orange one, because if we take any point from this orange line, it should satisfy the equation of x minus y should be less than or equal to 2. But if we take the points from the blue line,
yeah.
if I take 3, 0, then
Like 3, 0, right? It will be greater than 2, right? It will be greater than 2. Yes.
Can you explain?
Yeah, see, this blue shaded region here, right? So just pick a point, pick any point. So let's say I am taking in this blue region the point 3, 0, right? It lies in this blue region.
Okay.
So this x minus 5 will come out to be what? 3. So that is not going to be less than 2. It is going to be greater than 2, right?
Ma'am, if you take 3 and 0, if you take 4 and 1, then?
If you take 4 and 1, then what will it come? It will come as 3 again.
3.
So again, in this reason, whatever you take, the value is going to be greater than 2, not less than 2. You take 3, 3, 0, you take 3, 1.
But ma'am, how can we see this that it's greater than or less than 2?
Now you take some point in the orange region. So let's say take the point 3 and take y to be what, 2. Okay. That is in the orange region.
Yes.
Right. So 3 minus 2 comes out to be 1. So in the orange region, we are getting x minus y less than equal to 2, not in the blue region. Always in the blue region, we are getting x minus y greater than equal to 2.
Okay. Ma'am, but how you put this line x minus y equal to 2?
You can plot x minus y equal to 2, right?
No, I am not getting this.
Okay. Sure, this one. So you have x over here, you have y over here, and you have to plot x minus y equal to 2. Okay. So you put x to be 2, y to be 0. And you put y to be minus 2 and x to be 0. Okay.
Yes.
So you have 2 points, and this becomes, so the line that passed through these 2 points, this is x minus y equal to 2.
Okay.
So in the question, we had that x is lying between 0 to 5. So let's say this is our 5. So x is fixed. X is lying between 0 to 5. Okay. And y is greater than equal to 0, but y is also less than equal to x. So y equal to 0 is this line, right? This line is y equal to 0. So y should be greater than equal to 0. It means it should be in the first quadrant. That we know. Now y is equal to x. So y equal to x will be something like this. So y should be less than equal to x. Now we have this whole thing. This is our reason D. Okay. We'll say this is our reason D. Now what we have to find is what is the probability that x minus y is less than 2. Okay. So when x is 5, what should be the value of y here? 3, right? Because it's an equation of line for x minus y equal to 2. So when x is 5, y should be 3 here. Correct?
Yes.
So this point I can write it here as 5, 3. Now you have to check what reason is x minus y less than 2. You take any point, you pick any point in this reason. All right. So let's say I'm taking 3 comma 0. So if you take 3 comma 0, you know that 3 comma 0 belong in this blue region. This region, right? Let's mark it as A, B, and C. So in the region A, B, C, you have taken a point 3, 0. And here x minus y, if we do, it comes out to be greater than 2. You take another point, take 3 comma 1. Okay. So you take 3 comma 1, it will be somewhere on this line. Right? It will be on this line. So x minus y comes out to be equal to 2. Now you take 4 comma, let's say take 4 comma, if you take 4 on this line, it should be 2, right?
Yes.
So let's take 4 comma 1.9. All right. So it will come out to be 2.1. It is again greater than 2. So always in this region ABC, you will see that x minus y will come out to be greater than equal to 2. In this region, it is x minus y greater than equal to 2. So if we have to find x minus y less than 2, it is going to be the above region. So OAC, let's mark it D. Right. So this trapezium that you see here, trapezium kind of structure that you see here. So this is what you have to find. So as somebody said, we can do 1 minus probability of this region, right? This triangle. So any you can take any approach and try to find the probability.
Let us solve it geometrically itself first. So the area of triangle ABC is coming 3 square in it, right? Sorry, it is coming. Hello?
Yes.
Am I audible?
Yeah, you're audible.
Yeah, it is coming 9 by 2 because half into base, so base is 3 and then the length is 3 also, right? So that area of triangle is coming ABC is 9 by 4. A smaller triangle, I'm saying.
Ma'am, one query over here. Can we find out directly the area into it, because it's not written that it's a uniform distribution,
Yes.
right?
It is not, nowhere in the question it is written that it is a uniform distribution.
We cannot use directly that area thing, right?
We actually can, right? Because the
Isn't it a
distribution
uniform
is given that 2 by 25. So it has to be
Okay,
distributed, right?
Yes.
Okay, that way, yeah.
So by definition, you can use the area because from here we know it is uniformly distributed.
Okay, with that. Even if it is not mentioned, we can use that. No, I didn't get that.
Then finding the area of ABC is very easy, no, ma'am. 1 by 2 into 3 into 2.
Yeah, finding the area of ABC is very easy. So what is the area? Half into base into height. So what is the base? It is 3. And what is height? It is 2. So this comes out to be 3. Now what is the total area?
The
Height is 3, no?
Height is 3, ma'am. Height is 3.
Height is
okay.
Height is 3. Okay, yeah, right. Half height is 3, right? So this comes out to be 9 by 2.
Yes.
Now what is the total area? If the reason D?
25 by 2.
25 by 2.
25 by 2, right?
Yes.
So what should be the answer?
16 by 2.
Sorry?
16 by 2. 8.
Yeah, 16 by 2. That is
8.
Yeah, right. So once you find the area, what is going to be the probability?
A quick question. Why do we need to actually do all the subtraction and everything?
8 by
I know the
8 by 25.
Area is 9 by 2 of what is of my interest. The total area is 25 by 2. I can go by 9 by 2 by 25 by 2 direct, isn't it? It's anyway uniformly distributed.
It is uniformly distributed, right?
It's x is equal to y. That means the intercepts of y and x are same. As you already written it over there, 5, 3 and 3, 5. So it is 3 on each side of the triangle. So 3 and 3, if I use the area of triangle, I get 9 by 2. The bigger triangle is 25 by 2. I divide one over the other, isn't it, for probability?
0.32.
9
We
by
are finding
20.
probability of the other side.
But okay.
You need the area of the trapezium. So
You need the area of the trapezium,
okay,
right?
Okay. Sorry,
Yeah.
my mistake.
So this area, what is this area comes out to be? We've just found that it comes out to be 8, right? So area of this trapezium, that is 8 divided by this whole area, that is 25 by 2. It comes out to be 16 upon 25. So once you calculate this, you'll get 0.64. 0.64, is it? Okay.
12 by 5.
0.64, right?
Ma'am, can I ask a question?
Yeah.
Ma'am, I didn't understand that part about this distribution being uniform. Is it mentioned in the, was it mentioned in the problem?
No, it is not. Okay, I will just go back to the problem. Yeah, so this was the problem statement. Now you saw that you had a triangle, right? You had this triangle, this blue plus orange region, right? If you find the area of this triangle, it will come out to be half times base into height. So 1 by 2 times 5 into 5. So 25 by 2, correct? Now just go and look back to the expression of fx5. It is 2 upon 25. So from here we can say that it is uniformly distributed.
Got it, ma'am. And ma'am,
Okay.
one more thing. During the integration, I'm sorry I couldn't do the problem as I was traveling, but it occurred to me that what if we could have just integrated y from 0 to x minus 2 and then x from 0 to 5? Would that have not given us the answer?
Okay, so if you want to integrate y from 0 to
x minus 2 and integrate x from 0 to 5.
Okay, let's go back first. First, let's say I want to integrate first with respect to x. So what should the limit of x be?
X would be 0 to 5 and y would be 0 to x minus 2.
No, the limit of integration that we're taking is wrong. Okay, let's solve this problem using this integration method. So we had system 6 minus 2. So this is 5. This comes up to be 3. And half x. So this is our reason D. This is our reason D. This is x minus y equal to 2. And we have to find the probability that x minus y is less than 2. So basically we have to find this reason, right? This reason shaded in the screen. Okay. We have to find this. Now, let's say I want to do this from 1 minus probability x minus y greater than equal to 2. So I can try to find the probability for this yellow shaded reason. Okay. So once I do it, yes.
I have a doubt. If we take 1 minus probability of x minus y greater than or equal to 2, wouldn't that take the above region, above the shaded region?
Yeah, it will take the shaded reason. I'm trying to find this
Okay, ma'am.
So let's try to find probability x minus y greater than equal to 2. So this will give double integral 2 upon 25 dx dy. So let's say I want to integrate first with respect to x. So if I want to integrate first with respect to x, so I will draw a horizontal line. Now this is our reason of integration. Okay. So if I draw a horizontal line, I will see that my lower limit is going to be this point. Okay. And what is this point? This point is x is going to vary from 2 plus y. X is going to vary from 2 plus y to this 5. Okay. And now once you fixed your x and x, so your y is going to vary from just 0 to this point, right? This point is 3. So y is going to vary from 0 to 3. Once you solve it, you will get 2 upon 25 outside and 0 to 3. So 5 minus 2 plus y, that will come out to be 3 minus y dy. So it will come 3y minus y square by 2, 0 to 3. So this becomes 3 times 3, 9 minus 9 by 2, right? So this comes out to be a 9 by 2, basically. Right? So 9 by 2 times 2 by 25. It comes out to be 9 upon 25. Now this probability x minus y less than 2 was 1 minus probability x minus y greater than equal to 2, and this we got as 9 upon 25. So the probability will be, this probability will be 1 minus 9 upon 25, that is 16 upon 25, and it will come out to be 0.64. So both ways will get the same answer.
Ma'am, could you explain these limits, ma'am?
Explain this limit. Okay.
Limit is confusing.
Yeah, so we wanted to integrate first. Let's say I wanted to integrate first with respect to x. Okay, so since this area, this, let's name it, so A, B and C. So this area in this region A, B, C, if you draw a horizontal line, since we have to integrate with respect to x, so I will draw a horizontal line. I drew a horizontal line and I saw that this line is cutting this curve, curve x minus y equal to 2 at x equal 2 plus y. So you're fixing your y, right? Your y, if you are integrating first with respect to x, you're fixing your y is constant. So once you're fixing your y, so for that y, your x is going to be, so if you're fixing y, your x is going to be 2 plus y, right?
Yeah.
Correct. So x is going to be 2 plus y. So any y you fix, you will always get x varying from 2 plus y, the lower limit. Since this was our curve, x minus y equal to 2, okay? This was our curve. So any horizontal line that you draw, the first point that touches this curve, that point x is 2 plus y. It is not starting from 2. I cannot say that like lower integral of x is from lower limit is 2 and upper limit is 5. Why we cannot say that? Because see, if I say in every case the lower limit is 2, then what happens is you're not actually trying to find this reason. In that case, you're trying to find this whole reason, this rectangle over here. But this is not what we're interested in. We are interested in this red shaded region. Okay. So to find the lower limit, for every y you fix, you are going to have a x that is 2 plus y. So every point, so since this curve is x minus y equal to 2. So what is this x here? This x is nothing but 2 plus y. So this is our lower limit, and we know that the maximum it can go is till 5. Any line you draw, you can see that it is going from this line, this point. You can see that any line you draw, it is going from this point to this 5. You draw any line, it is going from this point, that is 2 plus y to 5. Again, you draw any line, horizontal line, you will see the lower limit is 2 plus y to 5. So this is how we are fixing the limit of x. Yeah.
Do you have any change in limit if I have to integrate with respect to y first? Like here we are integrating with respect to x first.
Okay. Right? Okay. Now the question. Yeah. So now the question to you is like, I have explained how do you take the limit of x. Now, if I have to integrate first with respect to x, so sorry, with respect to y. So we had 2 upon 25. Let's say I want to integrate first with respect to y. So what should we take the lower limit of y as?
Y will be 0.
Tell me, what should be the lower limit?
0.
0. And what should be the upper limit?
3. X minus 2.
X minus 2.
X minus 2.
Anybody else? Who thinks something should be different?
0 to 3.
0 to 3. Okay.
3.
Any other answer?
2 to 5.
Y varying from 2 to 5. Okay.
So x varying from 2 to 5.
Okay, you are saying y is from 0 to 3 and x is from 2 to 5.
No, y varying from 0 to x minus 2.
X varying from 2 to 5. Okay, this is what you are saying. If y is varying from 0 to 3, what should your x vary from? Okay, so if y is varying from 0 to 3,
2 plus y to 5. 2 plus y to 5.
2 plus y to 5, you are saying. Okay.
Yeah.
So remember, we are fixing, we are taking the limit of y first. Okay. Any other limit for y?
Ma'am, can I say?
Yeah, please tell.
If for the range of x from 0 to 2, we will be taking the value of y as 0 to x, and for the range of x from 2 to 5, we will be taking the value of y from x minus 2 to x.
No, I couldn't get you what you just said. Wait.
Can I repeat it?
Wait, let me write. Yeah, tell me.
Ma'am, when x is between 0 to 2,
x is between 0 to 2,
y will be between 0 to x.
Y will be between 0 to x.
And when x is between 2 to 5,
okay,
y will be between x minus 2 to x.
So what is this that you just told?
The region for y, for the shade, finding the area of the shaded region. So we will.
You are trying to find x minus y less than 2. Did you tell for this by any chance?
Oh, is it different? Yeah.
Okay. Okay. No.
Ma'am, is it different? The question is different. I'm sorry.
No, I asked like you can see the red shaded region here, right? This red triangle ABC. So what I asked is like in the first case, what we had done is we had fixed ry, we had fixed y as a constant, we were varying x. So we saw the limit of x will go from 2 plus y to 5, right? Now what we are trying to do is, now first we are trying to fix x and vary our y. So we want to vary y. So how should y vary? What should be the lower limit and what should be the upper limit?
Okay, what I said was wrong. Sorry.
Yeah. So any other answer apart from these two? That is y varying from 0 to x minus 2 and y varying from 0 to 3. Anybody else has any other answer?
We require to take in parallel line, madam, whether it is a y-axis parallel or x-axis parallel.
Okay, so let's discuss this.
Ma'am, of the two, probably the first one is acceptable. The second one is 3
Yeah,
is
so
always not
second,
3.
yes, second one is not right. The first one is correct. Y should vary from 0 to x minus 2. I will draw a clean picture here. So
It would be good if you please explain that why second is wrong.
yeah, y second is wrong, right? Okay. Drawing picture here. So I will just make this triangle. Okay, this red triangle I will just make. This is A, B, and C. So this is the probability that we're trying to find. Now, my question was, if we want to integrate first with respect to y, okay. If you want to integrate first with respect to y, so you had 2 upon 25 dy dx, okay. So how should y vary? So how do you check how the y vary? So what you do is you draw a vertical line. Whenever you have to take the limit, you have to find the limit for y, you draw a vertical line, okay. So once you draw the vertical line, you see that for any x you fix, let's say I have fixed this x, okay. Let's say this is x1. I have fixed this x, and how is my y varying now? So what is this point?
2 plus x.
No, this point is 0, right? So
that point is 0.
This point is 0. And so it is going from 0 to what is this point? So remember, this line is x minus y equal to 2. So this point is x minus 2, right? What is this point? This point is x minus 2. Now, similarly, you take any other line. You take any other line, and again, so any line you fix, any x you fix, you see that the lower limit of y is always going to start from 0, right? This is always 0, and it is going from 0 to maximum this point over here, right? And again, this point is what? X minus 2. Okay. So any vertical line you draw in this region, you see that your lower limit is always going to be 0, and your upper limit is always going to be a point on this curve, that is x minus y equal to 2. So y is always going to vary from 0 to x minus 2. Right?
Yes, thank you, ma'am.
X will be 2 to 5.
And x will be 2 to 5, right? Because you can see this point was 2 and this point was 5. Okay. So I hope how to take the limit is clear.
So x will be 2 to 5, right?
Yeah, 2 to 5, right?
Yes.
But how do we context the question here now? The question is,
the question was whether finding the probability using the area method and using the integration method was coming out to be same or not. So we had already checked, and we had got that in both the cases, the probability is coming out to be 16 upon 25.
Yeah, but the question is, can you put it on perspective?
Sorry, the question is?
Can you put up the question in perspective of the explanation what you had given now, where the leftover milk is at least 2 liters, something like that, no? From the graph, can you build up the leftover milk portion?
Ma'am, may I interrupt by a question?
Yeah, the leftover
regarding the limit.
milk portion is superimposed on the top of the x minus y is equal to 2, is it?
I couldn't understand. That trapezium is, this is the probability that you have to find. This is the probability that you have to find.
Green is the one which is the probability we have to find it out.
Yes.
Yes.
The probability of milk.
And what is the statement for that? The green one is representing what?
X minus y less than 2.
Can we revisit the question, please?
This is 2, this is minus 2.
Yeah.
This line is x minus y equal to 2.
Oh.
Right. Let's say this is our 5.
X is equal to y.
Let's, this is a very wrong picture. This is 5, this is 2, this is minus 2. This is x minus y equal to 2. And this is your y equal x, right?
Yes.
So it was given to us that x is lying between 0 to 2, 0 to 5. Okay.
Right.
So x is between 0 to 5. And this reason, okay, this reason is what we had to find the probability. So this reason is probability that x minus y is less than 2. So to find this probability, what we did is, since we know this whole triangle, let's say this OAB is the reason D, okay. So to find this probability, this shaded region, what we did was, we did 1 minus probability x minus y less than equal to 2. And x minus y less than equal to 2 was this triangle. Let's note it as C and D. So BCD is the new triangle.
Greater than equal to 2, man.
Oh, sorry, greater than equal to 2, right? So this is greater than equal to 2, right? So this probability, we found it to be 9 upon 25. And this one, okay? And once you subtract 1 from this, you get 16 upon 25. That is the probability for this shaded region here. Right?
Right.
Oh.
I hope it is clear.
Yes.
Yes.
Yeah.
No, but what is the statement in the question corresponding to that one?
Okay, so the statement of the question was, what is the probability that the amount of milk sold at amount of milk left at the end of a day is less than 2 liters? So X was given as the amount of milk that you had, and Y was the amount that was sold. So X, we had to basically find probability X minus Y less than 2.
Okay.
Yes.
Right?
Right.
Okay.
Thank you, ma'am.
Yeah, let's move to the next problem. All right. So problem is, the joint PDF of two random variables x and y is given to you, and it is defined as 3 by 2 xy for x lying between 0 to 2, y lying between 0 to 2, and x plus y less than equal to 2. Otherwise, it is defined as 0. Okay, so the first question was, find the marginal density of x. You can write your response here. Okay, so the first question is, find the marginal density
can you
of.
please show the question once?
Yeah, I will show the question. Just write it down, and once you find the marginal density of x, I will go back to the next page.
Just a second.
we have to find what, ma'am?
Yeah, so you have to find the marginal density of X. You can write your responses in terms of the variable, whatever you get. Okay.
Ma'am, how many more questions are we solving, ma'am?
Sorry?
How many more questions are you solving?
So there are 2 more. This is the 5th problem. You have 1 more problem.
Okay, thank you.
I think it will take another half an hour.
Oh.
So just let's do it first.
Done.
Yeah. So the first question is you have to find the marginal density of X. You can write your responses.
Actually, I written it in the chat box. I was unable to join again. To join PD.
You can go to join PD and.
No, I'm unable to join that.
Okay, then. All right, you have written answer 3x. Okay. That means.
Ma'am, can you move back to question?
Sorry, go back to question. Okay.
Yes, ma'am.
Can you explain?
Yeah.
Thank you.
Hmm.
Okay. Let's go to those responses. 3x 2 minus x by 2 1 3x 3x 3 by 4 x 2 minus x whole square x 2 minus x whole square by 4. Okay. I think 3x 2 minus x whole square by 4 and 3x is the common answer. Okay, so the joint PDF is given to you and it is defined as 3 by 2 xy for x lying between 0 to 2, y lying between 0 to 2 and x plus y less than equal to 2. So to find the marginal density of x, what do? We integrate our joint distribution function with respect to the random variable y, and we fix the limit of y. Okay. So this is how the graph will look like. If you plot the distribution, this is how the reason will look like. Now, since you have to find the marginal density of x, I will do the integration of fxy over dy, and again since we have to find the limit of y, to find the limit of y, I am drawing a vertical strip over here. Okay, so once I drew the vertical strip, I could see that your we are fixing our x, and after fixing my x, okay, our y is varying from 0 to this point on the x plus y equal to 2. And what is this point? What is this y that you will get? This y you will get as 2 minus x. So I will write my the limit of y is varying from 0 to 2 minus x. Okay, so I have put the limit of y to be 0 to 2 minus x, and since you have to integrate with respect to y, you will treat x as a constant. So we have to we are assuming that x is a constant, and this integral will become 3 by 2 x y squared by 2. So this will come out to be 3 by 4 x y square. Okay, and just substitute the limit of y over here. So 3 by 4x remains constant, remains same, and you will get 2 minus x whole square minus 0. So 3 by 4x, 2 minus x whole square. This is what you get the marginal density of x. Is it clear?
Ma'am, here x plus y is less than equal to 2. And the question is written. So,
sorry.
Ma'am, here we are fixing x, right?
We are fixing x, right?
So y is getting 2 minus x. I thought it was 2.
Y is getting 2 minus x, right?
Yeah, I thought it was 2 because
y 2
limit is from 0 to 2 for y. I mean, y is between 0 to 2.
That will happen only when it is uniform and rectangular block is here. Square block.
The limit part is clear to everybody?
No, ma'am.
No?
No.
Okay, so for the previous question, we discussed the limit. Okay.
Yes,
if you look at this expression, your x is between 0 to 2, y is between 0 to 2, and x plus y is less than equal to 2. So from there, we got this graph. Okay, that part is clear. Now, since we had to find the marginal of x, we do the integration of the joint distribution with respect to y, correct? That's what we are doing here. Now, once you are doing the integration with respect to y, you have to look for what is the lower limit and what is the upper limit of y. So to find the limit of y, whenever we are doing the integration with respect to y, we draw a vertical strip. Okay, so parallel to this y-axis. So once you draw a vertical strip, you see that your y is varying from this 0 to this point 2 minus x, right? Same as what we discussed in the previous problem, exactly same, right?
Okay, ma'am, because this is 2 minus x, so that is why you are taking this 0 to 2 minus x.
What?
Because
sorry?
x 2 minus x, as you said, we have put a line parallel to y axis.
So this is nothing but y. For this particular x, this is your y, 2 minus x. What is this point on the line? On the line x plus y equal to 2. On this line x plus y equal to 2. If you have taken x to be x, this point is what? Y equal 2 minus x. This is what I've written. So your y is varying from now 0 to 2 minus x, right?
Yes.
Is this clear?
Yes, ma'am.
Yes, ma'am. Okay.
Yes.
Yeah. Let's go to the next problem.
So whenever we are given with the joint PDF, and if there is a marginal density is asked for it for X here, so we got to differentiate the joint PDF with respect to Y and express the limit in terms of X. Is that right now?
Yes, yes, yes.
And if it is otherwise, right, if it is marginal density for Y, then it should be with respect to X,
with
and
respect
the
to,
limit should be expressed in the,
with respect to Y.
it should be expressed in the form, right?
Yes.
Thank you, ma'am.
Yeah.
Okay.
Ma'am, may I ask a doubt?
Yeah, please.
Ma'am, if X is discrete, then the marginal sum of marginal density of X over a certain.
So if X is okay, now if X and Y have the joint PMF instead of PDF, if they have the joint PMF, and if you had to find the marginal of, let's say, X, okay, so in that case we used to do sum of the joint PMF, and the limit of Y used to vary for Y, the limit used to vary for Y, like we are fixing X and varying the Y, right?
That is fine. My question is, when you add all the marginal density, it will be 1, right?
Yeah, it will come out to be 1 if you add all the marginal densities.
That is X is discrete. But in the case of when X is continuous, will it be 1 over a certain range?
Oh, not over a certain range, but like if you, okay, in this case, your this is between 0 to 2, right? X is between 0 to 2. Now, if you take for every X, I mean, for every X that lies between 0 to 2, if you try to find the marginal of X, then it will come out to be 1.
Can you further explain it? I didn't understand. For example, here it is 3 by 4x into 2 minus x, the whole square.
Yeah, so X is varying between 0 to 2, right?
Okay.
So X is between 0 to 2. So for every X that is between 0 to 2, this is the function. You put X equals 0 here, you will get 0. You put, let's take any point in between 0 to 2. Let's take 1. So you will get 3 by 4. If you take some other point, let's say 1.5, you will get some other value. And when you sum it all, okay, you should get the complete the sum to be 1.
So in that interval,
in that interval, it should come out to be 1.
Okay. Thank you, ma'am.
Basically, the area of the triangle is 1 now, is that right? That's what you are trying to explain.
Yeah, area of the triangle is 1. Yeah.
So the joint PM of X and Y individually is equal to 1.
Into y. In this case, it is area of the triangle is how much? Half.
Yeah, 2.
It is coming out to be
2.
It is coming out to be 2.
Not 1, 2.
2.
So the joint
Then
distribution.
how the sum will be 1? How the sum will be 1? When the area is 2, the sum cannot be 1. Am I right in my question?
Yeah, what you just told is right. So if you try to sum it over, it's 2 minus 6 square.
So how did we get that X plus Y is equal to 2?
Sorry?
We are given only the joint PM of it.
Yeah, we have already given the joint PM. It is coming from here. The expression.
So X plus Y is less than or equal to 2. So, yeah. So the statement that it should be equal to 1 is right.
By the time you can try to solve the second part, I will
then we can
solve it. Yeah.
Okay.
Yeah. For the same joint PDF, find the marginal density of Y.
Okay.
Yeah. So look at the responses. 3y 2 minus 5 whole square by 4. Square by 4. So it's coming out to be same, is it? Okay. See, everybody has written the same answer almost. So to find the marginal density of y, right? So we are going to do, we are going to integrate x with respect to, sorry, we are going to integrate fxy with respect to x. So if you do that, your limit of integration is going to vary from 0 to 2 minus y, right? So it's the same as the previous one. It's just the limit of integration for x here is varying from 0 to 2 minus 5. So any doubt in deciding the limit of x here?
No.
Okay. Yeah. So coming to the previous problem that we were just discussing about. So the sum of this fx, right? We're discussing that sum should come out to be 1. So fx, the marginal density of x is coming out to be 3 by 4 x2 minus x whole square, where x is between 0 to 2. So since this is a continuous random variable, we cannot sum it. In place of summation, we'll do the integration. So if you do the integration of this fx over the interval 0 to 2, you try to integrate it, you will see that it will come out to be 1. So the total, the sum of fx over this whole range of x should come out to be 1. And okay, and why we are not going to take, so we just said before that area of this triangle is 2. Okay, so you see that this is not a uniform distribution, right? This is not a uniform distribution, and the distribution of this function is given to be 3 by 2 xy. So if you try to integrate this 3 by 2 xy over this whole range, you will get as 1. You will not get as 2.
Ma'am, can I put it in a different perspective?
Yeah, please. Yeah.
See, you said the sum of what are we the area represented by a marginal probability is 1 for x, and for y it is 1. Okay, so both put together is 2, right? So that's what it is represented in this chart.
No, why?
Am I wrong in
So
that?
when do we take area? We take the area when we know that the distribution is uniform, right? And then we say 1 by mod of t comes out to be the joint probability, the joint PDF, right? But it is
Currently
not
we
a
are
uniform distribution. So you try to integrate this fx of x over this whole interval x, which varying from 0 to 2, you will see that you will get it as 1. Similarly, you have this joint density function here, and if you try to integrate this function, this joint PDF over this range that is given to you, it means that inside this triangle, it will come out to be 1 only. So you can take this as an exercise. You can take this as an exercise and try to verify that the sum of, if you integrate fx over this whole range 0 to 2, because x is taking the value from 0 to 2, you will get fx of x to be 1.
Sorry to bother you, ma'am.
Yeah. Yeah, please tell me.
Yeah, but if you look at the activity question, there you have questions where you have the marginal density as 1 by 2 or 1 by 4 if it's a uniform distribution. Why is that? Let's say activity is 6.2.
Let me check the activity. Which activity it is in?
6.2.
Problem number?
Both 1 and 2, where the options are marginal density of x and y are given. Their marginal density of x is 1 by 4, 1 by 2. For example, second question.
Okay, second question. You have, okay, x is uniform in D. D is, should I share this thing? Yeah. That's right. Is this activity problem? No. Yeah. So xy is uniform in D, where D is 0 to 1. If we plot this graph, so x lying between 0 to 1, y is 1 to 2. Okay, y is 1 to 2. So you have a triangle, let's square over. Then 1, 2, 1, 2, 0, 1, 2, 0, 1. Okay, and then 2, 3, and 0, 2. Okay. 2, 3, 0, 2. So we have different figure here. Okay. So yeah, what are you trying to say here? So what is fx? Fx is coming out to be 1 by 4 for x lying between 0 to 2 and 1 by 2 for x lying between 2 to 3.
Now my question is why it is not this, why the sum is not 1? As in discrete, you have sum of marginal density of any discrete variable over a certain range is 1.
Okay, so here if you try to integrate, you will get from 3.
For the
It is
first
1
one,
by 2. It is coming to be 1, right?
Yes, for the first one it is coming to 1, and as for the third one as well.
It is coming, right?
Yes.
Yeah, so I will do it for you. So what you do here is, see, you have for two different intervals, you have two different, the joint, the PDF, marginal PDF, okay?
Right.
So for x lying between 0 to 2, your fx is coming out to be 1 by 4, and for x lying between 2 to 3, it is coming out to be 1 by 2. Now,
Correct.
since you want to see whether the overall sum is coming out to be 1 or not, right? So you have to do integral of fx, right? 1 by 4. So let's take first for the interval 0 to 2. So for that interval 0 to 2, your fx is coming to be 1 by
Screen
4.
not visible, ma'am. Screen not visible.
I'm not solving it. I'm just
Okay.
explaining.
Okay.
You can try to do it on your own. Okay. So the first part will be 1 by 4 dx, where x is varying from 0 to 2, plus 1 integral 1 by 2 dx, where x is varying from 2 to 3. So once you solve it, you will get it to be 1.
Okay, okay.
Yeah.
Okay.
So since for two different intervals, your PDF is defined differently.
Okay.
Which one, ma'am, you are discussing now? Whether it's 1 or 2?
Question number 2.
Can you please follow?
Okay, this problem.
Yeah, it's not visible fully.
I'm sharing the screen, right?
Yeah, but it is stuck over 1, question number 1, but you're talking about question number 2.
Oh, is it for everybody?
This is practice assignment.
Yes, ma'am.
So I am sharing a different screen, is it?
Yeah.
Oh, okay. I didn't know that. Okay, yeah. This is the problem. Sorry.
Yeah, thank you.
So you see that if you do the integration, you'll see that the overall value will come out to be 1.
Thank you.
So, okay. Let's move to this part. All right. So the same problem, if you continue, whether now you have to check whether x and y are independent. So how do you decide on whether two random variables are independent or not? So we just check whether fxy is equal to fx of x times fx of fy of y or not. So you have seen it before that fx of y is coming out to be 3 by 4 x2 minus x whole square. Similarly, fy of y is coming out to be 3 by 4 times y 2 minus y whole square. Clearly, when you multiply these two, it will not come out to be
1.
Not 1. I mean, fxy, the joint PDF, that is 3 by 2 xy.
It is not.
Yeah. So you try to multiply fx and fy and you check whether it is coming out to be 3 by 2 xy or not. But if it is coming, it is independent. Otherwise, it is not independent. Okay. We can check this one. Let's move to the next problem. Okay, so this here you have xy uniform in a region D, where D is defined in such a way that is taking the value xy such that y is less than equal to 2x, x lying between 0 to 1, y lying between 0 to 2, union 1 comma 2 time cross 0 comma 2, and this is the reason that is given to you. So what should be the marginal density of y? This is the last problem that we have for today. So I'll give you a couple of minutes, then we'll move to the solution. All of you have noted down the problem.
Yes, ma'am.
Yeah, so go to the options part. You can write your responses. Let's move to the solution part. You can try to solve. I can see only 4 responses, so you can try to do it later, okay? Out of 4, 2 are B and 2 are C. Okay. So what? How many of you have solved this? Okay, Pankaj, you want to explain?
Yes, ma'am.
Yeah, okay.
Ma'am,
So
we have to
how
find the marginal of y.
Yeah, right.
So by plotting the area,
Okay,
we
we'll go
got.
to the. This is
Yes, ma'am.
reason D. Yeah.
Yes, ma'am. Then we got the area 3. Right.
Okay.
Then we got the joint PDF 1/3 f of xy, that is. Then we have to
Okay.
integrate from. Yes, ma'am.
Yeah, right, go on.
Then we have to integrate from x equal to y/2 to 2.
Yeah, correct. So what answer you're getting finally?
Ma'am, answer option B.
Option B. Yes, that is right. So we had so the way PDF was defined, joint PDF was defined. You had this reason over here, this reason D, the shaded reason that you can see. Now you have to find the marginal density of y, right? So to find the marginal density of y, what we do is we integrate over we integrate the joint PDF and sorry, we integrate the joint PDF with respect to x, right? So how is your x varying? To find the limit of x, what we will do, we'll draw a horizontal strip. So once we draw a horizontal strip, you will see that your x, the lower limit of x will be y/2 and the upper limit will always go to 2. So this is all we had to do here. So 1/3 dx y/2 to 2, and it will come out to be 4 minus y/6 for y lying between 0 to 2. So you can look at the solution later. So any problem, any doubt in understanding this? Yeah.
The critical part of such problem is to identify the limit only, right?
The limit only, yeah.
Yes,
so
ma'am, just for clarification, I'm asking this question. Since these are two different regions, right? Adjacent regions, right?
Yeah, right.
If I have to find out the marginal of x, right?
Yeah.
Then I will have to differentiate with respect to y, right?
You will have to integrate with respect to y.
Integrate with respect to y, right? So in that case, whether I have to proceed taking two regions separately, like for the triangle first, I will identify and then the square again.
Okay, that part I will leave it to you. As I know that is a graded assignment question.
That's a graded as a question.
Yeah, in graded assignment, you have to find marginal of x, I suppose. So,
okay, no
yeah.
problem.
So we have seen here how to find the marginal density of y. Similarly, you can check on how do you find the marginal of x.
In case of x, there are two different.
Yeah, so you will have to try to figure out how to do it. Okay. I will close the session. I will stop it here. Okay, so for week 6, yeah, we will give you some extra content because you have not studied even double integration in maths. So by the end of this week, we should be able to give you some additional content for week 6. And yeah, today was.
On Friday, we have next session, right, for week 7.
Friday, we have next session for week 7. Sorry.
Who is taking that session? Are you coming?
Can you repeat? Sorry, I couldn't
listen. Who is taking that session on Friday? Are you coming?
Friday, okay. I'm not sure. I will check. No, I will not be taking the session on Friday. Okay, so that's all we had for today. I will share these slides on portal. Anything else?
Thank you, ma'am.
Thank you, ma'am.
Okay, yeah. Thank you all for joining the session.
Thank you, ma'am.
Yeah, thanks.
Oh,
Thanks all.
thank you, ma'am.
Bye.
Thank you, ma'am.
Yeah, thanks all.